portfolio. Frontier Laboratories is a Japanese organization located in Kuriyama, Fukushima Prefecture, and we are actually celebrating our 32nd year. And we are global leader in analytical pyrolysis technology, and we are the manufacturer of this pyrolyzer and peripheral devices. We have three major product portfolio. One is the pyrolyzer, then the microreactor, and third one is the ultra-alloy metal capillary column. Our pyrolyzer is majorly or mainly used for chemical analysis of polymeric materials, mainly for polymer and additive determination. The microreactor is used in research studies on investigation of waste to energy studies, and also for rapid catalyst screening and catalytic pyrolysis and co-pyrolysis research and applications. Yeah, I think we will talk more about this Chemisorber during this webinar, which can be used for VVOC and VOC and SVOC analysis in food and environmental matrices. I just want to share how we are connected to this thermal desorption application. Our pyrolyzer is actually mainly used for pyrolysis. At the same time, the micro furnace allows you to vary the temperature for a different purpose. This is how the same device can be used for thermal desorption studies as well. So this schematic simply just explained how our PY system is connected to a GCMS. So this can be connected directly at the inlet of the GC. Then any changes you do in the furnace for the sample exposure, either like a ramp temperature or a fixed temperature for flash pyrolysis, the solutes or the constituents released from the sample will be swept to the analytical column for separation. Then subsequently it will be detected by the suitable detector. So you get something similar to a chromatogram, which we can call it thermogram for evolved gas analysis and pyrogram for pyrolysis. Okay. So our multifunctional pyrolyzer allows you to use the instrument for 4 different analytical techniques. Okay, one is evolved gas analysis, the second one is single shot, and the third one is double shot analysis, and the fourth one is the evolved gas analysis hard cut GCMS analysis. Okay, so the double shot analysis is something related to thermal desorption followed by the pyrolysis. So this is how we see ourselves connected to the TD-GCMS application as well. So just for the benefit of some of the participants who may be new to this VOC analysis, I just want to spend a few minutes to introduce about the VOC and their analysis by thermal desorption GCMS. Volatile organic compounds and semi-volatile organic compounds and even very volatile organic compounds refer to thousands of organic chemicals, okay, that are present as gases at room temperature. These VOCs and these SVOCs are atmospheric pollutants, okay, that can have adverse effect on human health, and some of them are known as carcinogens. So it's not only in the environment. So similarly, it is looked into the food, also in some of the materials, because some of these VOCs can have a positive or negative effect on the materials. So whereby one has to monitor the content of these volatile organic compounds. Also, the quantification of such VOCs are required even in material testing applications as well. For SVOC, as we all know, the major example can be this polycyclic aromatic hydrocarbons that is actually coming from this fuel combustion, and also this brominated flame retardants and phthalate esters. Okay, the table below shows the 3 category, the very volatile organic compounds, which actually have a characteristic boiling point of less than 0 to up to like 50 to 100. The second group of compounds, actually volatile organic compounds, can have a boiling point of 50 to 100 and almost like up to 260. So anything above 260 to like 350 or 400 is what is classified as a semi-volatile organic compounds. So the analysis of different VOC classes can be problematic due to their relatively low levels of occurrence. Okay, that means you really require some sensitive equipment. At the same time, we are trying to analyze these compounds from a complex mixture, due to which we also require to have certain level of selectivity. Thermal desorption is a very effective technique to pre-concentrate these low-level analytes. At the same time, you are able to remove the matrix effect and use the desorption, okay, as a technique to look at this adsorbed compound through GCMS application. As you all know, the TD analysis is a two-stage process. Firstly, it is actually kind of offline or online collecting these compounds and also pre-concentrate. Then at later stage, it will be thermally dissolved and analyzed by GCMS. So the secondary trap also is introduced in these days, okay, where it can collect all these, which called mostly the focusing trap, and that is rapidly heated to dissolve all these absorbed VOCs. Then it goes for separation and detection. So large volume samples of air samples can be done with this sorption tube. Then they can be thermally dissolved at the instrument for detecting these VOCs. So let me again explain this thermal desorption with the schematic. As you can see from this slide, the sample tube is actually initially heated for certain level of characteristic where it can improve the absorption characteristic, and afterwards it will go to the desorption stage where it will dissolve the compounds that are trapped in the tube. Then it will be analyzed by the GC coupled to MS. Okay, so there are like two stages. The initial one is trapping or absorption, the second one is desorption. So mostly the term thermal desorption is referred to the second stage where you are thermally dissolving the concentrated solids from the trap and get analyzed by the GCMS. In general, the TDMS application is approached in two ways. Okay, the type one is you are not using a trap, you are basically heating the sample and allow to look at some of the thermally reliable compounds and directly get them introduced to the GC for separation and analysis. The best example for this type of analysis is actually the additive analysis in plastic and rubber materials. As you all know, there is a standard, this RoHS, under which all plastic materials need to be analyzed for the phthalate, because phthalate is included in the RoHS restricted list of substances. And this need to be done with this thermal desorption, where you don't require to use a sorption tube. The sample can be directly heated and release the thermally liable compounds. Then it can be analyzed by GCMS. Another well-known example is degassing. Okay, in semicon industries, when they have this hard disk and other electronic devices, they are exposed to high temperatures, so which can cause a release of certain organic compounds. So this is generally done by this direct sample heating also. Another one is in heritage applications in museum, when they are storing a different kind of painting and painting materials. So if it starts elutes or like emits some of the VOC due to the different temperature condition in the museum, this is also something is regularly monitored to ensure that the indoor air quality is acceptable for people to visit the museum. So these are certain type of examples where we can see the thermal desorption studies are done directly by heating the sample without using a sorption tube. The second type is what we see here. The initial one is you heat the sample. Okay, sometimes if it is a water sample, you also have to adjust the pH of the sample. So that will accelerate the release of the volatile compounds, and it can be captured in the sorption tube. In stage 2, it will be released by instant heating at high temperature. Okay, so this is most commonly used TD application. So people always use sorption tube to collect the interesting or the list of interested VOCs, then thermally dissolves for the analysis. I'm just going to share a few list of applications where the TDMS is done by heating the sample directly. As I mentioned, in RoHS, all electronic materials need to be screened for phthalates. As per the current standard, there are 6 types of phthalates restricted. At the same time, we expect to have more type of phthalate will be added to the list. So here we show the analysis of 14 different type of phthalates that can be analyzed with our TD-GCMS application for direct sample analysis without any solvent extraction or even the sorption. The second example is actually the quality check on the volatiles or additives in rubber material. The characteristic of rubber material can be altered or influenced by the presence of different additives for this vulcanizing agent or anti-degradant or antioxidant or plasticizer. So as a part of quality check, they have to screen this material for the required additives to ensure the performance for the specific application. So this type of analysis where the customer is interested in additives in a rubber or plastic material can be done by a direct heating of the sample at this low temperature like 100 to 320 through a ramp. Then the dissolved or the thermally labeled compounds will be released from the material that can be analyzed by the GCMS. This is another application similar to the previous one. So the different rubber products can have a different type of these additives. So as a part of screening, so we can demonstrate how this can be analyzed. Okay, here we have taken 4 different type of NBR samples. Okay, natural butadiene rubber, and this is actually in complete characterization, we use evolved gas analysis and thermal desorption, and also the thermal desorption coupled with this hot cut analysis and pyrolysis GCMS. In today's presentation, I'll be sharing only the TD-GCMS parts. So when you do this kind of materials through direct thermal desorption, you are able to look at the presence of different volatile compounds. So that can be a plasticizer or antioxidant or anti-degradant or vulcanizing agent. So these are certain examples that uses the TD-GCMS where the sample is directly heated and analyzed. Okay, so it does not use any kind of trap for enriching these VOC compounds. So the type 2 is what is very popular. So within type 2, so we can also see most of other type of VOC analysis also, and even the SVOC applications use this thermal desorption at later stage. So we all know about the headspace. So headspace can be like dynamic and static. So in dynamic, what happens? You heat the sample and stir the sample, and the VOCs coming to the headspace will be drawn with the help of this gas and get trapped in the sorption tube. Then at stage 2, they are actually dissolved at high temperature. Same approach is considered in purge and trap also. In purge and trap, you have a water sample where you are interested to analyze the VOC. So you purge the water sample to expel these VOCs into the headspace. Then you have a trap at the end of this tube and this bottle, and where all these VOCs will be trapped. Then later on, it will be thermally dissolved to look at the presence of different VOCs. SPME, the solid phase micro extraction, also something similar, but this is not used for some kind of large volume. It's mostly for a small volume, because the name itself mentioned it's a micro extraction. So generally it has a polymer fiber functionalized or coated with this PDMS that can be applied for this VOC and SVOC analysis. So here also it's all like two-step process, where in first step the compounds of interest are trapped or absorbed. In stage 2 they are thermally dissolved for the analysis. And the fourth one is the sorption tube. So this is what most commonly people refer to TD-MS applications. Okay, so we have a sorption tube that can be used for different kind of trapping of different VOCs, either from clean air or atmospheric air pollution, or even from some using an air pump. You can also do some of the food samples just by pumping the air into the vial where the food sample is there. So this option tube is commonly used for this TD-GCMS application. So in Frontier, we have developed a small SPE or a device, or even it can be referred as SPME also, that can be used for both type of application. That means you can attach the instrument and do a kind of a low volume sample preparation and analysis. It can also use for air samples for large volume applications. Okay, so it can be used as a sorption tube. It can be used as a SPME. So this is what the benefit we see with this magic chemisorber. Okay, so what is a magic chemisorber? So magic chemisorber is a solid phase extraction device. Okay, it's basically a small stainless steel tube, or actually a titanium tube, that is functionalized with two type of compound. One is the polydimethyl siloxane (PDMS). The other one is the polyethylene glycol. So based on the type of functionalizing compound and also the thickness, it can show different properties for trapping different VOCs and SVOCs. Okay, so the first product that we have developed is called the Magic Chemisorber PDMS. Okay, so this is actually made by chemically bonding this PDMS layer into the titanium open tubular column. Okay, so the amount of PDMS can be varied based on depending upon the length of tube that you employ, you use it. So we have the typical smallest one like 6 mm to maximum of 30 mm. So the 6 mm one actually can be used for the automated analysis using our auto shot or the auto sampler, whereas the large one has to be used only offline sampling and like manual analysis. So that is a difference. But at least for the purpose of different applications, we have developed three different types of this magic chemisorber that has got different lengths, starting from 6 mm. The highest one is 30 mm. So I will explain this a bit later also. So the second product that very recently we have developed is actually polar type solid phase extraction, where we have used polyethylene chemical bonding on a deactivated SS tube. Okay, this also has shown a wide application for solid, liquid, and gas samples. So we will talk about it in at later stage. So this is one of the product. Okay, so this is a well established and also thoroughly evaluated product. Is a magic chemisorber PDMS. So this is used for environmental analysis, food analysis, and clinical analysis. So you have three different product. One is called the small S500, then L500, and L100. Okay, so particularly the small one, the S500, is actually having a length of 6 mm and OD of 2.5. This can be used through our auto shot, the auto sampler. That means you can automate your sample analysis. That will help you to increase the productivity in the lab. But some of the bigger tubes has got a large capacity, but that has to be used only through the manual sampling. And these 3D tubes or the Chemisorber is compatible with other brand of 3D system also. So it is not compulsory or mandatory to use our PY system for this application. So there are users who are just using our Chemisorber and attaching or using the second stage of thermal desorption with other type of 3D systems. So the second product is actually Polar Magic Chemisorber. So this one, as I said, here we are using polyethylene glycol as a stationary phase that is chemically bonded on this deactivated stainless steel tube. So the working principle is something similar to what you all know on this solid phase extraction, okay, where we are trying to extract the compounds of interest, particularly VOC or VVOCs, okay, by introducing this SPA element into the sample, either through direct contact or headspace. Okay, so you can use both approach. So the compounds of interest will be absorbed into the SPA element. Later on, you use the heating to desorb this and introduce to the GC for analysis. Okay, so this is very simple workflow, and this is well proven approach or technique for VOC analysis. So this is applied in food and cosmetics and environmental, clinic, and forensic analysis. Okay. So we want to share, okay, how we see our magic Chemisorbers, excuse me, the magic Chemisorbers are better, or at least in terms of the performance and characteristic. Okay. So we have two model or the two products. One is called this PEG, which is actually on a deactivated stainless steel tube, and the second one is the uh, titanium open tubular column that is functionalized with the PDMS. Okay, so this has got in two sizes. The MC 500 is 6 mm, and the PEG one is actually 12.5 mm. So how we do this, actually the cross-linked polyethylene glycol is chemically bonded on the layer of this deactivated tube, and for the PDMS is a cross-linked poly dimethyl siloxane. Okay, so the PEG is meant for polar compounds analysis, whereas the PDMS is for non-polar, but generally yes, semi-volatile compounds can be analyzed by this. So the thickness, okay, and also the volume of this coating can be measured also, and that is something we can control also. So our standard product for PEG comes with the thickness of 30 micron and the volume of this PEG available, because this volume define the capacity for enrichment. Okay, so it is 3.8 microliter, whereas the PDMS the volume of this coating is actually 20 microliter. So in terms of the maximum temperature, the PEG cannot go very high, so 250 is the maximum, whereas the PDMS, you can heat this tube up to 300. And this magic Chemisorber is reusable. So that means the same tube can be used for multiple analysis. How we compare our product with the standard other products? So in the market, you all know that Gestel make this twister. So that is actually ethylene glycol with silicon. And other one is the SPME also makes something called SPME PEG. Okay. So in terms of the substrate, they are different. So we use for PEG, we use inert or deactivated stainless steel, and twister use glass or stainless steel also. For SPME, is more like a metal alloy. So in our case, yeah, we only use PEG. They still use PDMS and PEG, and SPME call it only PEG. Okay. In terms of the length, so you can see they are comparable, and TD unit is necessary for our system and Gerstel. Whereas SPME, as you all know, you don't need a separate SPME system, the TD system. The inlet can be used as a like device or system for desorbing the soft VOCs from the SPME fiber or the SPME element. So you don't need to purchase a TD system if you are using only SPME. So that is sometimes people see it as an advantage. So in terms of the surface area, so ours is 128 millimeter square, whereas this details is not provided for the Gestal. And SPME, yeah, it's actually the small one, 7.2 millimeter squares. So in terms of temperature and cost, you can see this. So we are actually competitive in terms of the cost. At the same time, performance-wise, actually, we are actually same or better for different applications. So when you look at the evolved gas thermogram of this PEG of our sample versus the twister, you can see we have only PEG in our material, the Chemisorber. At the same time, if we compare the so-called PEG silicon twister, you still see many other things and less of a PEG. So sometimes you may not have similar capacity and for all type of very polar compounds. So this is what we see the importance of attaching or coating the tube with the PEG than PEG and other PDMS. So this Chemisorber can be used for headspace and direct immersion and also the gas sampling. Okay, so it can be used for all three type of sample preparation. So if you are interested in indoor air quality in a clean room or some of the atmospheric air quality monitoring, you just, or if you want to analyze some of the volatiles from a car inside the car, so you can use this kind of small air pump, the gas sampling device. Then you can bring it to, this is actually portable, so you can bring it to any location or any site and collect samples, then bring back to the lab for analysis. Okay, so you can do direct immersion, headspace, and gas sampling. So in terms of the analytical conditions, so you have this thermal desorption. This is recommended, okay, but one can always optimize this further for improving the performance. So for PEG based thermal desorption, we start from 100 and put a ramp of this 40 degree per minute and heat up to 230. As we said, the highest temperature is 250, so we do not want to go to the highest temperature all the time. So in the case of PDMS, you start from 100 and can go up to 280. Okay, then the gas GC condition, which I am not going to read out, and you can always do the full scan. Okay, so collect the TIC. Then if you are interested in certain specific compound analysis, you can always extract the ions for that particular type of compound that you are interested in. So the point, this Chemisorber can be used for three type of sampling: direct immersion, headspace, and gas sampling. So once you prepare your sample through either one of this approach, then this tube is directly dropped or introduced into the furnace, micro furnace, and set your furnace into this TD operating condition starting from 100 to 230 for PEG and 100 to 280 in the case of PDMS. So after desorbing all these VOCs or SVOCs from the Chemisorber, then you start your GC for the analysis. Then you get the chromatogram, so that can tell what kind of VOC you found in the type of sample that you are analyzing. Okay, I'm going to show a list of different applications. Okay, starting with red wine. As you all know, in particularly food and like beverages, people are looking at some of these flavor and fragrance. Okay, so here we show how this wine sample can be analyzed by direct immersion. So the matrix does not really interfere, because after you immerse for collecting or absorbing these volatile compounds, you take out and just wash with the rinse with the DI water, then dry it, then you can do the sample analysis with the TD-GCMS. So the first one on top is using the polar PEG Chemisorber, and the bottom one is actually the PDMS. So you can see, because in wine you expect to have a lot of polar compounds. So obviously that shows the benefit of using the polar chemisorber to detect many of these carboxylic acids, alcohol, phenols, ester, and even sulfur compounds. So this slides basically shows the applicability of both Chemisorber, both the PDMS and PEG. At the same time, the PEG is able to collect and determine many more of volatile compounds than PDMS. So the choice of Chemisorber is important based on your application and objective. So this is another application where we are showing the use of Chemisorber for direct immersion. Okay, soy sauce. As you know, soy sauce is a thick kind of liquid. So one may think that it may contaminate your Chemisorber. Okay, but we just demonstrate it does not. So okay, so when you put this Chemisorber into the soy sauce, and it only collect this VOCs, and you take out and wash with DI water, then you can basically do the analysis with the TDMS analytical condition. So again, this is very obvious that we see the PEG is good for collecting many of these carboxylic acid, alcohols, aldehydes, phenol, esters, and sulfur compounds. So definitely for this kind of application, PEG based Chemisorber is recommended than the PDMS. Okay, PDMS does show some of them, but actually, yeah, in terms of even the enrichment also, you see more intense peak with the PEG. That means it's able to trap. So the pre-concentration factor also is good for PEG than the PDMS. So this is another food matrix. This is a Cocondo. So just, yeah, again showing, because just for the comparison purpose, all these samples have been analyzed by both this Chemisorber, PEG and PDMS. But our conclusion is to show that the PEG is good for this kind of applications. Okay. So again, yeah, we show the presence of carboxylic acid, alcohols, aldehydes, and phenols, and we can see more number of compounds detected with the PEG, and not only the number of peaks detected, also the peak intensity. That means you have the better sorbing capacity, also the affinity with the polar device than the semi-polar device. So this is apple juice. Okay, so done by direct immersion as well. So in apple juice, comparatively, you are not seeing too many compounds. Okay, it has ethanol and also this methyl butyl acetate and acetic acid, formic acid. But here, interestingly, you can see more compounds, okay, detected even with PDMS also. So this is based on the chemistry, okay, of these VOCs. So isobutyl acetate and ethyl butanate and also ethyl 2-methyl butanate are actually found in the PDMS Chemisorber, but they were not really trapped by the PEG. So similarly for ethyl hexanoate and hexyl acetate. Yeah, so sometime if you are trying for new type of sample where you do not know what is the best one to use, it is recommended to evaluate this during the initial investigation, and based on the final results, you can make your SOP to use either PEG or PDMS, or in some cases you may require to do both. Yeah. Okay, here the analysis of NATO, and this is by Headspace. Okay, Headspace also, again, yeah, we can use this Chemisorber as a single device for different type of applications. So in this case, you can see more number of peaks are detected with PEG compared to PDMS. Okay, so this is what you will see the difference between the two type of Chemisorber for different type of samples. And so during the initial evaluation, you have to make your objective clear and choose the Chemisorber accordingly as appropriate. So this is the analysis of cheese. Again, headspace, because the cheese is a solid, so we cannot really immerse. So we have to go for headspace only. So with the headspace, yeah, you can see the presence of the carboxylic acid, alcohols, and esters. And this case, you can see that you are seeing more peaks even with PDMS also. So this kind of application, sometime one may have to use both of this chemisober. That's why actually Gestel trying to prepare a device that has both PEG and PDMS. But sometimes if you are not able to show the type of absorption capacity for both group of compounds, then you may still require to do this separately by using two independent chemisober of this PEG and PDMS. This is another application on this polymer industry, rubber plate. Okay, so when you have this rubber for car, right, so you want to make sure that it does not really have too many volatile compounds. Otherwise, if you use this the rubber liner on the windows, right, if it emits some of these VOCs, that may not be good for human health, or sometimes you have these odor issues. So this also has to go through certain QC to qualify this material for that kind of applications. Okay, so here you can use headspace, okay, because it's a solid. So we just have to do some kind of heating, and whatever the compound that are really released from the sample will be trapped at the headspace. Then you do the analysis with the TD-GCMS system. So here you can see more compounds are trapped by the PEG compared to PDMS. But in PDMS, you also see some of the hydrocarbons are like collected. Okay. So this is one kind of indoor air quality check, we can say. So this can be applied to even clean room analysis, or even same sampling can be used for external air pollution analysis or monitoring as well. So in new car, sometimes you have some kind of smell, that is due to certain group of VOCs. So you can test the type of compounds emitted in a car, inside the car, by using a small air pump with our Chemisorber device. So what you see here again, the use of PEG is better than PDMS because it's able to trap many type of VOCs. Yeah, compared to the PDMS. Okay, so it shows mostly the presence of carboxylic acid, alcohol, aldehydes, and phenols. Okay, so in summary, what I'm trying to highlight out of these several studies that we have done between the PEG and PDMS, okay, the polar element is able to collect more of these highly polar VOCs. At the same time, for certain compounds, you may have to use this PDMS. So this is what we have seen in certain application. Some of the compounds what we found in the PDMS Chemisorber was not extracted by the polar element. So based on your application, you should be able to choose one, either of one or sometime both. Okay, but the number of applications that we have demonstrated in this presentation have shown that the polar element can detect more of these polar compounds from different samples that we have analyzed than using this PDMS. Okay, so this is what one kind of conclusion, but this cannot be applied to all type of analysis also. So this is another applications where we can show, okay, so this is recycled resin. So if you look at this, you are able to see more compounds, okay, with this non-polar column compared to the other one. So it is not necessary that every time you get all these compounds trapped or detected using a PEG. There are some group of compounds VOC that you will see the PEG, the PDMS has got better affinity and absorption capacity. Okay, so in such cases you have to use that the PDMS based Chemisorber. So what we have shown so far is actually Chemisorber is a kind of SPE or SPME device that can be used for two type of analysis. Okay, one is You can do it something in lab, or you can also go to the field for any kind of collecting different VOCs from air samples. Okay, so for indoor and kind of outdoor air quality, and it can also be used for headspace analysis, also the direct immersion. So this can be used in three different ways. Okay, whereas this is something not possible with other sorption tube. So this Chemisorber has got the characteristic of two type of application which is commonly used. One is the SPME, the other one is the sorption tube. Okay, so this Chemisorber can be used as a sorption tube for air samples. It can also use as a SPME for headspace and direct immersion analysis. So with that, I would like to wrap up my talk here. So Chemisorber, Magic Chemisorber is a promising tool for SPE applications, and Frontier Lab has developed two types, PDMS and PEG, to analyze wide range of VOCs. It is applicable for air, liquid, solid samples in food and environmental matrix. It can be used for headspace sorption and immerse in liquid sample, also for collecting air samples. So we have shown wide range of application from food matrices and also the indoor air quality from new car, analysis of recycled materials and rubber materials. So if you have something new that you wanted to know, also possible. Okay, so yeah, if you have any questions, please let me know. So I will try to address it now, or sometime I may have to talk to our R&D team if I don't have the direct answer. Thank you for your kind attention.